Well, one place where the principles of scaling and similarity is used extensively would be the production of scale diagrams. Because unfortunately, a lot of things in life are either too big or too small to fit onto an A4 page. So, for example, if we have, say, a car, we want to reproduce the image of a car, yeah? To produce it to scale would be way too huge for our piece of paper. So we draw a smaller version of it. Yeah, so the car, we have the whatever. And of course, doors. Yeah, door. Now have a look at our car. Cars, how big are they? They're usually between, say, 4 to 5 meters. Yeah? Let's, make it easy. Let's say it's 4.5 meters. Yeah? But we measured in the diagram, it's only 4.5 centimeters long. But in real life, it's actually 4.5 meters long. What we're doing here is we are actually establishing the ratio. The distance in the diagram, 4.5 centimeters in the diagram, is equivalent to 4.5 meters in real life. So let's unify the units. And we convert it for 150, yeah? So the ratio, if you remember equivalent ratios, 4.5 divided by 4.5 will convert to 1. And this one divided by 4.5 is 100. So this is the scale of the drawing. How much units in the drawing equals to how much units in real life? Well, how many units and in the drawing equal to how many units in real life? So 1 centimeter in the drawing equals to 100 centimeters in real life. 1 millimeter equals to 100 millimeter. 1 meter equals to 100 meters, and so on. It doesn't matter, it just means that 1 part in the diagram equals to 100 parts in real life. One way this is used extensively is in maps. So let's have a look at this one. A Department of Land 1 to 25,000 topographic map. So in these maps, scale is 1 to 25,000. Well, what does this mean? It means that 1 unit in the map equals to 25,000 units in real life. So 1 centimeter on the map equals to 25,000 centimeters in real life. And 1 kilometer equals to 25,000 kilometers, and so on. So how we apply these units, let's take a ruler again. Let's just measure the size of the grid square. Yeah, the grid square across is 4 centimeters. Yeah, so grid square is 4 centimeters wide, which means correspondingly it should be 4. So 1 times 4 is 4. So 25,000 times 4 is 100,000 centimeters. Yeah. So in case the grid square, the width of a grid square, which is measured 4 centimeters on this map, is equivalent to 100,000 centimeters, which is 1 kilometer. Yeah. This is 1 kilometer. Somewhat useful piece of information. It doesn't only work for the large things. It works for small things as well. Let's say something that is way too small to portray effectively on a paper. Okay, let's try Okay, let's try a paramecium. So it's one of those small things, swims in stagnant ponds. A very simple organism that doesn't really do anything. It just swims in the stagnant water. So here's an oral groove through which it eats stuff. A macronucleus, so it has a large nucleus, and several small nuclei, and then there's some other weird organelles that supports the functions of its cells itself. So the size of these things are usually about 150 to 300 microns, which is like 0.15 millimeter to 0.3 millimeters. Obviously way too small to actually try to draw it to scale, because it will be smaller than these dots. If we try to draw it to scale, it will be like smaller than the dot here. Now, but we have enlarged it, and let's say this is 0.2 millimeters, and we measured it's actually 4 centimeters long. So in the image, the thing is 4 centimeters long, yeah? But in real life, it's 0.2 millimeters, yeah? Okay, so the convention is the image, the diagram is always on the left, and the real life is always on the right. So in this case, obviously we try to convert the unit to make them the same. We have 40 equals to 0.2. Well, ratio. Of course, we convert it one of them to 1. So obviously this one times 5 equals to 1 times 5, 200. Well, in this case, all it means is that 200 units in the diagram means 1 unit in real life. So if it's, say, 200 millimeters long in the diagram, it's only 1 millimeter long in real life. And this is the important part. If the diagram is smaller than real life, then the small number is always the front and the large one at the right. And if the diagram is larger than real life, then the large number is the front and the 1 is on the right. That's pretty much it.